zamykamy. Safe. Ciśnienie klasyka. Ok. Wszystko działa. Hello and welcome to Frog Manual, an unusual episode because this is the brand new conversion for the M249 GBB from VFC. Bam! Probably you've seen the video of the Frog special where I assembled this super cool M249 GBB from VFC, all steel parts, all I could get, mounted into this gun. Quite a lengthy video, some real steel parts, really nice and heavy. And in this video I mentioned that there will be coming some additional videos with the topics related to M249. So we are starting our series with the Frog Manual, and we will convert it to HPA. However, as most of you probably know, or like everybody who's interested in this knows, in general the M249 to convert it to HPA is extremely simple. There is the connector for the magazine in here. You just remove it and you can screw in either some aftermarket part that just fits there, or you can buy a special adapter from Crusader or different company and just connect the hose here and you have the HPA. Yeah, so very simple. However, if we look from the top, then the hose leaves to the side and goes like, you know, perpendicular. And I've seen many different solutions. Either people leave it like this, or they use some 90 degrees connectors to change the direction. This hose is like, you know, hanging around here. There is the ammo box underneath, so it's all get tangled. I don't really like that solution. So I thought how to make it in a nicer and better way. And the first thing I thought about is to route this inside of the gun. And I actually was almost able to do it, but there is one small issue where to exit with the hose. Because right now you see this stock is foldable. We could leave somewhere here under the receiver and the stock joint. But one thing, it would be very uncomfortable for the hand, because the hose would go like, you know, you can imagine like this, or it would even collide with the locking feature here on the stock, because you see how big this is. Yeah, so I said, okay, this is not the way. However, still I don't like the way how it exits perpendicularly. Maybe this is a good solution for some vehicle mounted M249. For the moment, let's not make too much spoilers. So I figured out something different. So in this episode I will show you how to make a simple HPA homemade conversion. No need of any CNC parts or anything like this for the M249. How to make an quite decent, elegant solution, in the sense that we will not impact the parts too much and the hose will be organized somehow nicely. First, before we look into the parts that we need for this conversion, I will very quickly explain what I'm thinking about. So what I want to do is to route the hose out of here back inside, make it leave through the side of the magwell here, and run along the receiver under those two screws, like attached, yeah, so not loose but attached, and then exit to the side along these welding points. This way the connector would be kind of like hanging here, but it's on the side, so no issue for the stock to close. It will be far enough so that your hand has enough clearance, so it should also not be an issue, and you will be able to drive it a little higher or lower depending on your preference. Also for the left-handed shooter, if the hose ends somewhere here at the end, so you could imagine maybe like this. Even if you will shoot from the left hand, the connector will bend a bit and will allow the hose to go there, yeah? So if you switch hands with a machine gun or you just left-handed, it should anyway be okay. This modification will not be complicated. I will remove the optic for it from the gun so that it's a tiny bit easier to maneuver with this beast. And here we have all the components that I will be using. So of course I have the hose. It's 6 by 4 millimeters. 4 is internal diameter and 6 is outer diameter. We will need less than half a meter of it. I have my black sleeve that I usually use to cover these hoses. Some heat shrinking tubes, exact specs will be in the description. This is a special kind of spring for hose protection. You see that it's extended in the diameter towards the end. So again, I will put the spec in the description. There are two small 3D printed parts we will use as some kind of hose retainer. They are identical. Again, model will be in the description. And two connectors. This is 1/8 of an inch thread, and here on this side I have the screw-in connection for my 6 by 4 hose. And this is important that it's not a QD, it's a screwed connector, because we will do a big bend in the hose at the exit and the regular QD would not seal, yeah, so it has to be screwed. Then there is of course the second side connector. I also use these screwed ones. This is US type, and a piece of black rope. Okay, so now we will remove the magwell here. When the magwell is removed, we will drill a hole in it, route the hose through, attach it under those two screws with the clips, and then finish the hose attaching it in this area. So it's really simple. As I believe not everybody knows how to remove this magwell, I will show it right now. And for this, the best way to proceed will be start with some field stripping. First we will need to take out the bolt carrier assembly, so push out the pin. Okay, then we can break the stock. And here inside there is the spring guide. So how to show it, this gun is too big. I guess you know how to field strip it. You just need to push it in and up and it will come out. And then when you pull the charging handle on the other side of the gun, you see that you move the bolt carrier to the rear, and now you will be able to pull it out completely. One more thing, the gun has to be on fire. I think on safe you will not be able to do it. Both the bolt carrier and the spring guide are not necessary for this mod. We will not be changing it, so just put it aside. And we can close the stock or remove it completely. I will for the moment close it. Now to make it a little simpler, if we look from the top, there is one screw here that we would like to remove. It's quite tiny, this one. What it does, it basically keeps in place the feeding tray here on the bottom. So if I remove it, it will just start to rotate or move upwards. Okay, so my screw is out. And you see how I can now lift this. Again, maybe this is not mandatory, but it will be a bit easier. Okay, so now we have to rotate the M249 like this. And if you look into the shell ejector, which is open because I pulled the charging handle back, so in your case probably it's opened too, you will notice that there are two screws. So here inside there is one screw in this place and one screw in this place. Yeah? And if we remove them, this outer part, that magwell, will basically fall out. Yeah, so I'm very quickly removing those two. And you see that the part fell off, yeah, on its own, actually, in my case. So here we have our part. On this side you have these fake welds that fit to this part that holds the box magazine, and maybe it could be clamped a little with it. In my case it fell off, and you actually see that the screws I undid, they stayed in the hole, so I'm okay with it, they can stay and wait. And here we have that connector. So if you have trouble with replacing it with like Crusader connector, yeah, you can just, you know, do the same and remove it. And we removed the bolt carrier because it would, you know, cover the access to those screws. This was the reason. Okay, so now you can grab any universal key or sized key, and you can just undo this. Yeah, you see how easily it went. I applied almost no force. Now I can remove it by hand, and we have the connector. It has a seal O-ring. Yeah, nothing special. So these parts we can put aside. So now to visualize this again, as I said, the hose would go from here, bend it to this first screw like this, the second screw, and then out. Yeah, you see that I'm using these polyamide hoses, which are kind of stiff. I use it for all the conversions. You can also use the polyethylene. It's up to you, it's much softer. However, in this case you will face some issue, because the target is that this part would originally be here, right? So I want the hose to go like bended 180 degrees and then lift to the side. So the width for the bend will be very small, and it will be very easy to break the hose. So you can imagine if, for example, I have a piece of hose here, if I, you know, overbend it, it will do like this, yeah, and it's broken and this is not usable anymore. So for this reason I need a pre-bent hose, and I'll explain you now how to make one. So here I have my pre-bent hose that is already prepared. So you can imagine that right now if I assemble it here, it's already so bent and without any breakage that it will be easy to fit it, and it doesn't give so much resistance, and it is not broken anywhere. Yeah, there is some specification on these hoses how small the minimum bending radius could be, but we can kind of override it a bit and create something like this. How do we do it? I printed this hose bender. So it's a piece of plastic, very simple, where you can just take the hose, yeah, and insert it. Of course you have to be careful here not to break it and so on, but if you try, yeah, gently, you can insert this, yeah, use the counterpart, okay, and if you are just careful enough you can close it, then attach one small screw through the middle here so that it doesn't open on its own, and you can leave it like this like 2 or 3 days. You will see that after you remove the screw, this hose will be almost permanently bended to some shape like I have here. You see that it's not copying fully this shape, yeah, but it's already much easier to maneuver with, and it will be much easier to get it to the shape I want. So again, the hose bender for this case is in the link in the description video. You can download and print it and use it. So still before we do it, we need to check where the hole would be. So I will drill a hole here on the side, and this cannot be like a regular round hole because it will be too small, yeah. So what I want to achieve is that the hose is routed here underneath. So the best is if I look here, so that the middle of the hose is somewhere below this edge, yeah, because if it's above this edge I will run over the screw, and I want to be under the screw, so probably something like here. Plus, as I said, a single circular hole will not be enough. The hose would be exiting at an angle, so I will need like an ellipsoidal hole, and for this reason I'm gonna drill 2 holes next to each other and then join them either by, you can do it by Dremel or by some file. I will show you the result when I finish how it looks like, and it will be clear then. Right now let's drill it. You don't need to remove this part in order to do it. However, when we route the hose out here, this part will be kind of useless, and I don't like how it's, you know, so loose here. So later we will have a look into how to improve this too. Actually, if you can imagine, you will make the hose like this, maybe the hose will actually push it, but we will increase this spring range a bit so that this part stays opened, not moving like this. I don't really like it. Okay, so let's put the M249 aside and let's focus on these holes. And here I have my part. So this hole has 7mm height and 13mm width. Actually, you could probably go to like 12, depends how your hose will bend. But important is that it cannot be just a round hole because it could cut here, as I said. Actually, maybe it will be a bit easier right now to remove these parts. Here in this gap you can see there is this tiny locking disc that we will need to remove. I don't know how you call it professionally. Yeah, the C-clip, I know. Yeah, so if you remove this C-clip, yeah, we can also put it aside not to lose it. Right now you will be able to just push out the pin, yeah, and both the spring and the locking plate will come out. So we can do the quick fitting. We can see how the hose fits in here. I already know that mine fits. I want my hose to finish just before the bend, so I will cut it somewhere here. In that tube bender device I need some excess, but right now I don't need it, so cut it clean, and then I can attach it to this screw-in connector. This is very simple, you just push it in. Okay, and then you need to put the nut on the other side and just tighten it. So now the nut is partially tightened. I still can rotate this in the hose, yeah? So the hose rotates because I don't know what will be the final position here and I want it to go to the side. So this connector has an O-ring, but I don't trust them. I will use Loctite sealing adhesive. So we apply it on the thread. This is the red Loctite, and you just screw it in. And you can screw it in quite easily by hand. I will anyway tighten it with this universal key. I think this should be fine, and I can rotate the hose to the direction I want, and now I can tighten this nut till the end. Okay, the next step before I push it through the hole on this part will be to assemble the sleeve. So I have my pre-cut sleeve, and I will put it into this spring because I want this to, let's say, come in one piece. It will be just a bit easier. Again, the specs for these parts are in the description. Okay, so this part is prepared. I will also insert this smaller heat shrinking tube onto the hose. So just slide it over. Okay, the next step will be to put the hose through this the magwell. Then we will put the sleeve over as the last part, and you see how this spring is done, so the sleeve doesn't go to the very end of that, yeah. And we put in this side first. I'm not mentioning any dimensions because this is all up to your build, yeah, whatever length you like and so on, so you should probably figure this out for yourself. This is more like an idea video how you could do it than a real frog manual, yeah. Okay, so I push it here, you see I have it, this sleeve is here, the spring is here, and now I can assemble it. Okay, so now I will need to have this a little further from each other, so here we go with the sleeve through, yeah, like this. Okay, inside to the magwell. Now I can move the magwell away, and I would be able to, you know, have the heat shrinking tube here, like insert this over the sleeve. I will shrink it in this position. So I use some heat gun, yeah, it's shrunk. I can slide it back to desired length. Later I will glue it in place so that it doesn't move. And right now I can take my magwell and just push it in place with this hose hanging out, and you will see that the hose will not break, it will bend the way it should because I pre-bent it earlier. And as I push it in, I want to attach those two screws again. So you can also do it this way, that when you are you know, pushing it, you can catch the screws before the final position and pull it into the position with the screws. It will be a bit easier. It will be very hard to do under camera though, so I will do it off screen and I will show you how it looks like. And you see how this is attached. So I managed to not break the hose. It's going out like I wanted. Actually, it's so sticking out so much that it will hold my plate here nicely, and there will be not needed any modification for it not to wobble, but it's just fine. I opened the feeding tray to make it a bit easier, so the screw was removed, you know, I could do it easily. And also here you see these fake welds are like, you know, this steel part is in the middle of those two, like I showed from the bottom, so all is good. Now I can just close the feed tray cover and we can finalize our assembly. Let's move the gun just a bit. So like, this was the most difficult part. It's really to make sure that this part, the hose in here doesn't break. If you make it without breakage, it will be just fine. And I suggest you use this stiffer hose because the soft one is extremely easy to break. If you use the tube bender like I did here, it should be just fine. To finish with one side, we will first assemble back this cover. I already tried that it's, you know, very stiff and I don't need to modify the spring. In general, the spring would go, how to show it, maybe here. The spring would go like this. So one, this wire sticking out would go under the plate, and the second one would go under this top wall of the magwell, yeah? And it's basically, you know, too close to each other, they don't spread the part enough. So the simplest solution to do it, and I will do it right now because the spring will wobble if not this cover, is to bend it a little. So if you look on the spring like this, you see that it has like a almost right angle, and we want it to be a bigger angle. And you see how I bent it, yeah? So right now it will push more on this locking plate and basically the spring will not wobble. The pin will go here, then the plate will come, okay, with the spring already. And I will have to push this plate a bit because the hose is sticking out so much, yeah? So I push it. I am able to push the pin partially through. Now the spring, so I need to compress these wires. One goes under the plate, one goes under this magwell top wall, like I said. Again, it's hard to show what I'm doing exactly. I believe it should be clear though from the description. Okay, and now the pin through the spring, okay, to the plate, and again I will have to push it down on this side so that it can go through. So I struggled a little, but it's there. And the C-clip, now everything is at such tension that probably the C-clip is kind of like useless, but anyway we can put it in. So the C-clip is in. Of course at this stage we could put this screw back, yeah, so just for formality. Okay, we can close it. And now some finishing steps. So first I will attach the connector to this hose, and then I will attach it to the receiver of the M249, and I'll be using the connector you've seen. So remove this part, and I can still slide this on the hose. Generally the nut will be here inside of the spring, so I kind of positioned it like this. I need to cut off the hose more or less here where the spring ends, yeah? So first I will cut it off. Okay, this would be the proper length. Now I can slide it away, and before I do the next step I will also insert this heat shrinking sleeve over the spring. Now I can throw in the nut, I can push in the connector in here, okay, till the end. And now when I will be screwing this, I need to leave here some gap because the spring will catch in this gap. The spring is from 1.2 the diameter wire, so I need at least 1.2 millimeters. Okay, now I can take this and pull it back. I need to push in the spring over the nut so that the tip of it ends in this groove here. So you can see how it looks like. The tip of the spring is here. And now I can just slide this sleeve over the connector to hide it, yeah, depending on the wishes, yeah, like more of this, less, yeah, up to me. This is a solution I do in the HPA GBB pistols. Maybe some of you actually know it. Maybe I'll cover the whole spring so that it doesn't scratch on the receiver. Okay, and then heat shrinking. So you see how it's prepared right now. I could just leave it like this, but what is worrying me that, you know, it will be moving around and it will break sooner or later here. So we will do two mitigations. For this we will need those two clips. So I printed them of PETG with carbon fiber, one of my favorite materials. we need to unscrew those two fake welds. Yeah, these are actually screws. So we will remove this one, and we will remove this one. And under each of those screws we will put this clip so that it holds the hose down. Make sure to tighten it nicely, yeah. Okay, so one is here. And the second one is here. So from the perspective of this band connection to the gun, I believe the hose is fully secured. And now there is a question, because theoretically it could break also here, or if you run around a lot, you could basically break off this clip. Good thing is that there is the second clip and they are printable, so they are kind of cheap. So two options: either you can leave it, or you can do what I'm about to do, which is also a solution taken from the pistol conversions. I will put this piece of black rope, yeah, it has to be thin. So I will put it through this steel plate here, like this, and I will attach the hose here. Why like this? Because this rope will be much harder to tear apart than to break the plastic part, and I can kind of drive the position of the hose with it. You will see what I mean in a second. So I can take it, and I will do it 2 times in a sense, yeah. So here we have one loop, and then I'm gonna take those 2 ends and tie a knot in here. Okay, so if I do it this way, I can make this piece of rope just a bit longer, a bit shorter, up to me, and this way I can orient the hose more straight or more down. And here you see that this is kind of flexible, it moves. Maybe actually sooner or later it will be cut by this steel part, but I'm not worried about this because I can replace this very easily, and it has multiple levels of damage protection, because there is this rope, 1 clip, 2nd clip before it gets here, yes. So it's a lot of safety mechanisms, yeah. So I want to point it more or less like this. Definitely it will be out of way for the hand. I will connect the HPA here nicely, and you see that if I bend it, yeah, if I hold this rope like this, if I bend it to all the sides, I don't really transfer any load to the clip here, yeah. I can move it here, move it there, whatever I do, it's kind of okay. For the field stripping, this pin has to be removed, but this clip actually, or this sheet metal, doesn't, because this pin, when you push it out, it has a lock that will hold it in place, so theoretically it will never fall apart, yeah. So for field stripping this should not be an issue too. Okay, so I tie a knot, keeping this length, as I said, to my liking, yeah. Tighten it. Okay, and as always, to prevent it coming loose, what I do in these cases, I just take a bit of like Loctite type glue and apply it on the knot, yeah. It will basically make it deadly stiff, and then I can just take a knife or pair of scissors and cut off the remains. And now you see the HPA is connected, the hose runs here. I can lift the gun, so you see how the hose faces away from my hand. So it should be very practical, and I think it's a nice clean solution. Much better than routing it through, perpendicularly through the magwell. Very simple. Again, this is not real conversion. I just used few parts from the hardware store and I assembled it, so you see everybody can do it. One thing I did not do yet, I did not put in back the bolt carrier group and the return spring. You do it vice versa to what I showed how to remove it, so I believe you can figure this out. You can put it back, reload it, and we can take some shots. So let's see how this works on HPA. So here is the nice M249 already converted to HPA. It's really handy, so the hose doesn't bother me, and my hand, you see it's here going to the body, and I will now connect it to the pressure and I will make some shots to show you how it works. What is important is of course that This is not the standard stock M249 because I have the 20-inch outer barrel and the inner barrel, of course, and I have also the hard kick, so I have increased the weight of bolt carrier group. And yeah, other than this, I believe it's pretty standard. So I will have to take unusual angle this side because the connection is in here. Okay, so now let's connect the HPA. And I'm using mini Redline SFR 120 PSI, the usual thing. And here with the M249, this thing with the safety, meaning cocked hammer, all this stuff, doesn't really work because M249 is made completely different way. But of course, in this gun we should also make sure that the gun will not shoot immediately when we connect the pressure. So there are two modes in which it operates. It operates in the training mode or the regular mode. How do we set it? If we look in here, there is a switch, and if this switch is very small here, if the switch is set to the back of the gun, it means that it's training mode. If we move it to the front, it will be the regular firing mode. What is the difference? The difference is that in training mode the gun will shoot regardless of it having BBs in the chamber or not, and in the regular mode it will stop shooting where we have no BBs. So if we are in the training mode, the bolt carrier right now pushes on the valve, and if it would be the regular mode, it would not be pushing on the valve. Yeah. So if I blow right now through the hose, I don't know if you can hear it, but I can blow through because this is training mode and the bolt carrier is forward. So here it's a little more complicated than in your regular AR-15. So what I will do is, first of all, take it off safe, yeah, so the red circle visible, and now I will move the bolt carrier to the rear because then I am sure that the valve is closed 100%. Okay, the bolt carrier is positioned to the rear. Regardless of the mode I can close it, and right now the valve is closed. I am not able anymore to blow through. So here it comes, my 120 PSI, and I need to listen for some hissing or something coming out of the gun. The maximum pressure in this case depends on the components you used. Yeah, my components I used are rated for higher pressure than the regular conversions, but it's just my case. If you use different materials, you will get different maximum pressure. So we can lift the gun up, and right now when we start to shoot, let's see how it goes. So it's off safe. Maybe I can show it again from this angle. You will see how the bolt carrier cycles here in the ejection window, and let's take some quick shots. Okay, so the gun cycles really nicely. Of course, remember about relubing and this stuff. So gun cycles really nicely, but I also want to see if for sure I did not bend it, the hose, broken it or something like it. I already know what the rate of fire will be. It will be 12 rounds per second, but I also want to see if I have a decent power output, yeah, muzzle energy. So for this reason I will quickly chrono it. Okay, so for the chronoing I will use 0.36 gram BBs, 120 PSI on mini Redline SFR as I said. And as I said, it already has increased weight of the bolt carrier group, so the rate of fire is kind of slower. It also uses the real firearm stock, which has a buffer that slows the rate of fire down. Yeah, so with the original VFC buffer it would be a little quicker, but that's not my target. My target is to be 1.9 joules on these 0.36 gram BBs, and I probably will be higher than this because I used a very long tight bore barrel. And in the next video I will have to make some NPAs probably, because this gun doesn't feature one. but for all VFC guns it's quite simple to make one, so who knows, maybe you should hang out till the next one and you will see some cool information about this. Okay, let's go to the chrono. And this is all for this episode of the Untypical Frog manual, which is not really a manual but more like a guide of how to do it. DIY HPA conversion for the M249 from VFC, the other way how people mod it on the internet, something you can do yourself. I hope you like it. This is an awesome gun, so let's field more of them. Thank you for watching. Subscribe, comment, like, hit the notification bell, and hold on for next videos because there will be a lot of more materials for the M249 and other GBBRs coming in the future. And for now, maybe the power of GBBR be with you.